Let's take a look at the first problem for chapter 10, problem set number 1. You had to name the following compounds. Let's start with this one. When you have an alcohol, then you know that you will end the name with OL. This is the case if the alcohol group has the highest priority. If you have a double bond and an alcohol group, the OH will take priority, so the name will still end with OL. Later on, we will learn that when you have more than one functional group, for example, carboxylic acid and an alcohol, then you had to choose which group has the higher priority. And we will learn that later on. But for now, an alcohol, this is the group with the highest priority so far that we have seen. Okay? And when that is the case, you want to give it the lowest number. So we start here, 1, 2, 3. So you could go either this way or continue down here. Keep in mind that we want to find the longest chain. So we go 4, 5, 6. The longest chain that does include the group with the highest priority. If you want, you can highlight so you don't get confused that main chain. And then let's take a look at the substituents that we have. We have a substituent here. This has 2 carbons, so this is ethyl. And here we have one group with just 1 carbon, so we call that methyl. Okay, and keep in mind that you cannot forget your stereochemistry here when indicated. So decide if it's R or S. This group will be the one with the highest priority, followed by this, that is 2. So when you take a look at this, will be 1, 2, 3 are the one that you don't see, you know, that is hydrogen, and that is your number 4. So we go from 1 to 2 to 3 to 4, and that is clockwise, so that is R. And we list the substituents in alphabetical order, so we end up having R, 3 ethyl, 4 methyl, and the OH is on carbon number 2. So 2, and because we have 6 carbon for the main chain, the longest chain, then that is hexanol. Okay, let's take a look at the next problem. It was A, now B. Okay, you have a double bond here, you have the OH. The OH group will take priority, so we know we will end the name with OL. Then let's put the numbers 1, 2, 3, 4, 5. You have a double bond on carbon number 2. And when you have a double bond, you need to know if it's going to be E or the Z configuration. In this case, we have it as E. The groups with a higher priority are on opposite sides. So we would have E. Then the double bond starts on carbon number 2. So 2. You have 5 carbons for the longest chain, so pent. En to indicate that you do have a double bond. And the OH is on carbon number 1, so 1 OL. Let's take a look at the next one. For C, here you have the OH and you have the double bond. So the question is, how do I begin with the numbers? but you want to give the group with the highest priority the lowest number. So that group is the OH. So that will be carbon number 1, 2, 3, 4, 5. Because this carbon, this sp2 carbon is attached to 2 hydrogens, then this double bond does not get that classification of the E or Z. So the double bond is on carbon number 4. You have 5 carbons for the longest chain. And your OH is on carbon number 1. Let's take a look at the next compound. Once again, we have the OH and we have the double bond. You want to give the OH the lowest number. So this is a ring. Let's take a look at the configuration R or S. So this will be 1, that group will be 2. You want to see it this way, will be 1, 2, 3, and the hydrogen, that will be 4. From 1 to 3 to 4, but 4 is facing you, so you reverse this. So you end up having the clockwise direction, so that is R. So R to cyclohexene, then 1. So that is the name.